let's see the operation of binary search tree in the operation of removing. That is to remove a node from the binary search tree. After that, the structure of the search tree will be kept with the required properties. So how can we achieve it? So we have to consider the following three cases. One is the element is in a leaf node, which is simplest case. Then the second case is the element in a degree 1 node. Or the elements in a degree 2 node. Remember what we mean by degree? That is, degree 1, it means that it only have one child. If the element is in a degree 2, it means that it has 2 children. Okay, let's see. The first case is to remove a leaf node. So if you refer to the tree we have constructed, the example we have used, we would like to remove, for example, the node with key 7. So to remove it, just break this. Okay, it would complete the job. And another example, okay, if you remove 35, so just remove it. Okay, it will be fine. So how about if you remove a node with degree 1? So let's see. For example, we would like to remove the node with key 40. So you can imagine that it's actually we're breaking this link and then reconstruct the new link. Okay. So just break it and we connect this 20 to 30. So the required tree structure for BST can be retained. So let's say another example. Okay, we would like to remove 15. So the case is like this. Okay, again, we would like to build a link from 10 to 18, and then when you break this edge between the 10 and 15, then you can have the tree structure for BST reserved. So the last case is for the degree 2. So it is taking more steps to complete it. So let's say an example. You would like to remove the node with key 10. So if you remove it, you have to determine the new tree structure, whether you would like to move the left child to replace it, what I mean is left sub the child from the left subtree, or the one from the right subtree. So in this case, you can replace the largest key in the left subtree of the deleted node. For this case, it would be 8. Okay, or okay, you can choose another option, okay, which is the smallest right subtree. Okay, in this case it is 15. So in the following example, okay, we will just make use of the largest key in the left subtree, okay, so that you can have better understanding. As a consistent example. So in this case, okay, we would like to replace the largest key in the left subtree of the deleted node. So first, as you would like to remove 10, okay, so you find that, okay, 8 is the greatest smaller number, so it will replace the nodes in 10. So the first step is to duplicate the node here for 8. After that, you have to rebuild the edge between 6 and 7, because after this move, this remaining node attached to the original 8 must be degree of 1. So after this reconstruction, and then you can break the link between 6 and 8, then job is done. Let's see another example of removing a node of degree 2. In this case, okay, we try to look at, okay, is it the same? Okay, we remove the root. Okay, so here again, okay, we remove the root, okay, which the key is 20, and then, okay, again we will replace it with the largest left subtree. So for this case it's 18. So again, okay, it is duplicated as the root node, and then the link between the original position of 18 and the 15 is broken. Then a new tree is formed that still obey the structure of the BST.